AN. It is still a more specialized address. We talked about address classification before. You will find that it is subnet. If the routing protocol does not support VLSM. For example, this network segment is finally transmitted to this device. It learned, but not supported. Don't care what the data is. In the end, it will only learn and spread according to the main class. That is, the final data goes here. For this device, it passes 172.16.0.0 16-bit mask. Because the main class of this address is a Class B address. Then the device will eventually propagate and learn according to the Class B address. Then if the device supports VLSM, it issued 24. Then what it learns is 1.0/24. So if the device does not support VLSM, what it actually learned was wrong. Because it is obviously a 1.0/24. It learned a 0.0/16. This is definitely not right. So this is what we call VLSM. Okay. Let's finish the last point. Finally, there is a support for WANs and LANs. This is what I just told you. When EIGRP first came out, it supports the use of the wide area network. That is, support use on the public network. Why not now? Because it appeared relatively late. When it comes out and wants to open the market for free, the entire internet is deployed. And it charges. So gradually it will be forgotten by everyone. How much have you forgotten? Many people only think that EIGRP is a Cisco proprietary protocol. Just like OSPF. Many people don't even know. It used to be deployable on the public network. Actually, this agreement is really powerful. Now only used on IGP. But in a moment we will learn about its configuration. Everyone should know. It will have some corresponding AS number configuration. When we are learning EIGRP as a whole, there are 3 tables. Look. Neighbor table, topological table, and routing table. When we learn OSPF in the next class. Also 3 tables. Neighbor table, topology table, routing table. Both of them are the same in this case. The overall timing is not quite right. So whether it is technology or market, timing and opportunity really matter. Okay. Let's take a look at these tables. For dynamic routing protocols, its appearance will be more. Because you can only see static routes in the routing table. It has nothing else. Static routing does not have a static routing table. But dynamic routing will have a lot of appearances. Because it's complicated. So many tables will be generated. Let me tell you the contents of the table first. For example, there are now 2 devices. EIGRP is running between the 2 devices. Then they will exchange messages with each other. They interact to do hello packets. Is a greeting message. Then after the exchange of this message, the 2 of them will establish a neighbor. It's like you open the door and say hello to your neighbor. You 2 will be neighbors from now on. Once the 2 devices establish a neighbor, each will generate a neighbor table. The contents of the table. It's the picture I'm showing now. Let's take a quick look. First look at the first H here. 1 is 0. 1 is 1. This is the order in which neighbors are established. In computer language, the first digit is always 0. The second digit is 1. So it means that the following is the first established neighbor. The above is the second established neighbor. This is the order between them. This is just an identification. The following is more important. This one is called address. Please be careful. Whether it is the EIGRP we are talking about today, or OSPF in the next class. This representation is called the neighbor table. There is a very important word in the neighbor list, called I see the neighbors. That is, parameters seen by the device in the neighbor table. Not its own parameters, but the parameters of the neighbors. So this address. It is not the address of the interface of this device, but the neighbor's address. Everyone can see. This device is R1. Then according to the current overall configuration specification, it should be XXX1. But what you see here is the address of point 2. That is, here the device looks at the neighbors. It looks at the address of this interface of the neighbor. This is the address inside, instead of the address of the interface of the device. Due to more appearance, people often get confused when viewing. So I emphasize here, is the neighbor's address not the device's address. Include interfaces whose interfaces are also neighbors. Neither is the device's own interface. Go down and look at this uptime first. This is how long the neighbor lasts. That is, devices and neighbors greet each other. From the beginning to the present. The time they've been together. Don't look at the following parameters. This will be discussed at the NP stage. None of these 4 parameters will be mentioned. You will learn the protocol mechanism in the future. After learning the message, learn them again. Let's finally talk about this hold, called duration. EIGRP is not only about establishing neighbors, but also to protect the neighbors. Then EIGRP sends a hello packet every 5 seconds. Then, if the device does not receive the other party's hello packet within 15 seconds, on behalf of the device thinks the neighbor is down now, the device will revoke the neighbor. That is, it thinks the neighbor is gone. It is removed from the appearance. Then this hold means every time the device receives a hello packet from its neighbor, it will refresh this to 0. Then start counting up. If you haven't received it in 15 seconds, it won't want this one. As long as the device is in the process of countdown. If it is received within 15 seconds after reading, becomes 0. Refresh. Becomes 0 again. Rebrush. It's like a timer. It's just timing. Count down from 0. Stop when the timer reaches 15. That's what I mean. I give a real example. You should go out to say hello every day. Suppose you say hello to your neighbor every 5 days. Then you find you opened the door and saw him after 5 days. You greet him. He ignores you. You say hello again. He still ignores you. 10 seconds passed. Say hello again. He still ignores you. 15 seconds passed. You think this person doesn't want to talk to you. You don't want him. You think this person doesn't reply to your message. Is he gone? The 11 here is. It's been 11 seconds now. The device has not received. Sometimes when we are doing experiments, this parameter is not particularly accurate. So it's enough for everyone to understand. Look down. This is a topology table. What does topology table mean? Let me tell you first. There is a routing table in the back here. This is very familiar to everyone. There is a D here. I'll explain what this D means in a moment. Let's go back and talk about this topology table. The topology table has an all links here.